In this video, we are going to do some true-false examples involving limits. So the examples in this video are going to be more conceptual in nature, and that can mean that they are more challenging. So be ready to spend some time thinking about these problems, and don't be surprised if you're not sure what to do right away. That is really natural with these types of questions, and spend some time before we make some progress. All right, so true or false? If true, show why. And if it's false, then give a counterexample. Part A is the statement, if the limit as x approaches 4 from the right of f of x equals 1, then the limit as x approaches 4 of f of x equals 1. Okay, so I want to begin by giving you a chance to try this problem. So pause the video for 2 minutes to try this question. 4, 3, 2, 1. Pause the video for 2 minutes to try this question. It's really important, particularly on the true-false questions, to give yourself a good chance to think through it before watching us talk about it together. Alrighty, so hopefully you've done that. Hopefully you thought about it for about 2 minutes and tried something. Even if you weren't sure, that's okay. But I do want you to be trying something, even when you're stuck. Alright, so this is saying that the limit as x approaches 4 from the right is 1. And then it's asking us, okay, does that mean that the limit as x approaches 4 overall has to be 1 as well? Well, no. For the limit as x approaches 4 to be 1, both the limit from the right and from the left have to be 1. So we're thinking that this is false. And it says if it's false, give a counterexample. So let's draw a counterexample. I need to draw something where the if portion is true, the limit as x approaches 4, let's draw 4 on the x-axis, from the right is 1. Let's put a 1 here. So as you approach 4 from the right, you need that limit to be 1. Maybe let's draw a hole here. Okay, but I want the overall statement to be false, which means I need this conclusion, the limit as x approaches 4 overall, to be 1. I want that to be wrong. So I need the limit as you approach 4 from the other side to be something different. So maybe I'll have it be 3 from the other side. So let's give a quick explanation here. The limit as x approaches 4 from the right of f of x does equal 1, like I need it to be, but the conclusion that the limit as x approaches 4 overall, the two-sided limit, that is not equal to 1. That's D and E. That means it is not equal to 1, like I need it to be. So this is a counterexample showing it's false. So next, let's talk about some general strategy for if-then statements and how to show that they're true and how to show that they're false. What does it take? So in part A, I have this if-then statement. It said if some limit statement and then something, something, something. So in general, to show an if some stuff, then some stuff statement is true, we must explain why. And now I'm going to introduce some terminology. So the if portion of an if-then statement, I usually call this the given. Or if there's multiple parts to the if portion, I call it the givens, plural. And then what follows the then, I call this the conclusion of the if-then statement. So for an if-then statement to be true, we must explain why the givens holding, which means the givens being true, means the conclusion also does. Okay, so when the givens hold, if that means that the conclusion also has to hold, has to be true, then the whole if-then statement is true. If I want to show the if-then statement is false, like I did in this above example, we have to give, one of the ways is we give a counterexample. Give a counterexample where the givens hold, meaning the givens are true, but the conclusion does not. So the conclusion is false. All right, let's look at part B. This says, if the limit as x approaches a of f of x exists, and the limit as x approaches a of g of x minus f of x exists, then the limit as x approaches a of just g of x exists. All right, so just to get us started thinking about it, I do want to give you a chance to try it, but before I do that, I'm going to help a little bit. I'm going to just say, okay, because it tells me that there are these two limits that exist, let's just call their limits something. So let's let the limit as x approaches a of f of x, let's let this be L1, or L1, since it exists, this has got to be some finite number. I'll just write a hashtag to indicate it's a number. And the same thing has got to be true about this other limit, the limit as x approaches a of g of x minus f of x. It tells me that one exists as well, so let's just say that this is L2, and that is a finite number because the problem tells me that limit exists. Okay, that's going to be my hint. Start there. And now pause the video for 2 minutes to try this. 4, 3, 2, 1. Pause the video and try this for 2 minutes. It is a conceptual question, and I know that this type of problem can be challenging, so don't be surprised by that. Even if you're stuck and you have questions, that's okay, but I want you to try something. Alrighty, so hopefully you tried it for about 2 minutes. That probably wasn't enough time to finish the question, but that's okay. Let's start to talk through some of the ideas together. So one of the things that this kind of reminds me of, this setup, is it reminds me of some of the limit laws. And part of what the limit laws say is, if you have some limits that exist, and this problem tells me the limit as x approaches a of f of x, that one exists, and the limit of g of x minus f of x, that one exists, then that I can combine those functions, this function and this function, in ways like adding them together or subtracting them. And I know what that limit's going to be. The limit laws tell me, or multiplying them together. So is there something I could do to those two functions, f of x and g of x minus f of x, to get the function g of x? That's my question. I'm going to ask you to pause it for 30 seconds to think about that. What can I do to f of x and g of x minus f of x to get g of x? 4, 3, 2, 1, pause it. Pause it and think about that for 30 seconds. Alrighty, let's talk about it together. So what I can do is add them. This is reminding me of the addition limit law. This is reminding me of the addition limit law. Okay, so in fact, by that addition limit law, because these two limits exist, the addition limit law says, oh, if you take the limit of those two things added together, so f of x added to g of x minus f of x, it tells me what that is supposed to be. It tells me that that is going to be equal to the limit as x approaches a of the first function, f of x, plus the limit as x approaches a of g of x minus f of x. Okay, and then if I simplify the left-hand side, what I get is the limit as x approaches a of the f of x's cancel, and I just get g of x. That's the limit I'm trying to say something about. And on the right-hand side, this first limit of f of x is L1, and the second limit of g minus f, that is L2. We know L1 and L2 are finite numbers, so when we add them together, this is still going to be just a single finite number. And that means that this limit of g of x, this limit exists. This limit exists. Okay, so we have shown that when the givens, so the givens are this portion, the if portion, this is the givens. Then the conclusion, this whole then part, that is the conclusion. Sorry, let me back up one sec. We've shown that when the givens hold, when they are true, when both of those limits exist, then the conclusion also has to be true. It has to hold. The limit of g of x is also going to exist, which means this statement is true. Alrighty, let's look at one more example, part C. This one says, if the limit as x approaches a of f of x and the limit as x approaches a of g of x both do not exist, then the limit as x approaches a of f of x divided by g of x also does not exist. I want to give you 2 minutes to try this question first. So pause it in 4, 3, 2, 1. Pause that video and try this for 2 minutes. Alrighty, so hopefully you paused it and thought about this for 2 minutes. That may not be enough time to finish the question, but that's okay. If you are stuck, my goal is for you to try something, even if it's completely off the mark. That is okay. Okay, so I have these two limits that don't exist. This kind of reminds me of limit laws because I'm dividing two functions, but the limit laws begin by saying the limit of f and the limit of g both do exist. And that's not what this is saying here. It's worded differently than the limit laws, which makes me think, maybe there's a way to find a counterexample. So let's begin by thinking of some limits that we know that don't exist. And the classic example that I can think of is the graph of 1 over x. The graph of 1 over x is this hyperbola shape, and as x approaches 0, that limit definitely doesn't exist. So here's kind of a sneaky thing. What if we let f of x be that 1 over x function? But it would be really nice to come up with a counterexample where, so to come up with a counterexample, when I divide f by g, I need that limit to exist. What if I just let f of x be the same as g of x? What if I let both of them be 1 over x? And I got to specify what a is. A is going to be 0 because then the limit as x approaches 0 of 1 over x, that does not exist. Okay, so we have come up with an example where the givens, so the if portion, here's the givens. The givens hold, the limit of f and the limit of g both do not exist. But now we need the conclusion, that's the then portion. Here's the conclusion. We need that to be wrong if I'm trying to show this is false. So let's look at the conclusion. But when I take the limit as x approaches 0, and now let's divide them, of f of x over g of x, we will get the limit as x approaches 0 of f of x is 1 over x, g of x is 1 over x. This simplifies super nicely. The limit as x approaches 0 of 1, and now that is just 1. And because this is a finite number, that means that this exists. So we've come up with a situation where the limit of f of x divided by g of x exists. Okay, and that shows that this is false. All right. So what I want to end with is just kind of like a useful function. So sometimes where you have to work with examples of D&E limits, I'm going to give another useful D&E limit that can be useful in these true-false questions in particular. And it's a piecewise function. So I'm going to let f of x be -1 if x is less than 0, and I'll let it be +1 if x is greater than 0. So if I draw my axes, this function has a y value of -1 if x is less than 0. That is on this side. And then this is not defined when x is 0, so I should put a hole here. And then I'll put a tick mark at +1. And my function is +1 if x is bigger than 0. That is on this side. And then a hole here again, because it's not defined when x equals 0. So this is just for reference. Sometimes in true-false questions, this function can be useful. Alrighty, going back to our goals for this section. I forgot to check off that we did squeeze theorem in the previous video. But now in this video, we finished our last goal, which is to take a look at some more challenging, these conceptual true-false limit questions.